The universe is full of wonders. Among all these marvels, one object captures our imagination like no other: the black hole. It's a place of pure mystery, a cosmic question mark hanging in the void. Black holes are where the rules of our world break down completely. They are the ultimate cosmic enigma, beckoning us to unravel their secrets. This mix of unseen power and profound mystery makes them incredibly compelling. They remind us the universe still holds deep secrets, waiting for curious minds. The universe is waiting, and its greatest secrets are hidden in the dark. Let's turn on the lights and take a look. So what exactly is a black hole? Let's break it down. Imagine taking all the mass of a giant star and squeezing it into a space smaller than a city. The result is a black hole, not an empty hole, but matter packed into an impossibly tiny area. Its gravity is so powerful not even light can escape. That's why black holes are invisible, perfect patches of darkness in space. They warp the very fabric of space-time, creating a deep well from which nothing can return. Black holes are the universe's ultimate gravity wells, where the laws of physics are pushed to their limits. Black holes don't just pop into existence out of nowhere. The most common kind, stellar mass black holes, are born from the death of truly massive stars. We're not talking about stars like our sun, we're talking about cosmic behemoths, stars that are at least 20 to 30 times more massive than our own star. Throughout their lives, these giant stars are in a constant battle with themselves. The immense force of gravity is trying to crush the star inward, while the nuclear fusion happening in its core is pushing outward, creating a delicate balance that can last for millions of years. But eventually, this cosmic balancing act must come to an end. The star runs out of fuel for its nuclear furnace. When the fusion stops, the outward pressure vanishes in an instant. With nothing left to hold it up, gravity wins the battle in the most dramatic way possible. The star's core collapses in on itself with breathtaking speed. This catastrophic collapse triggers a spectacular explosion known as a supernova. For a brief period, this single exploding star can outshine its entire galaxy, blasting its outer layers into space in a beautiful expanding cloud of gas and dust. While the outer layers are blasted away, the core of the star keeps collapsing. If the original star was massive enough, no known force in the universe can stop this implosion. All of that matter, the equivalent of several suns, gets crushed down into an incredibly small, infinitely dense point. A black hole is born. The star that once lit up the cosmos is now a region of infinite gravity, a ghost left behind after a violent and fiery death. It's a beautiful and terrifying example of the life cycle of stars, where creation and destruction are two sides of the same cosmic coin. So the next time you look up at the twinkling stars, remember the dramatic story some of them are destined to live. While most stars will end their lives more peacefully, the largest among them are fated for this spectacular demise. They live fast and die young, ending their lives in a supernova explosion that seeds the universe with heavy elements necessary for planets and life. And in their final moments, they leave behind one of the most mysterious and powerful objects in the cosmos, a brand new black hole, ready to begin its long, dark reign. To truly understand a black hole, we need to look at its anatomy. It's not a solid object with a surface you could stand on. Its structure is defined by gravity's effects on the space around it. The most famous part is the event horizon. Think of it as the point of no return. Here, the escape velocity equals the speed of light. Nothing, not even light, can escape. At the center lies the singularity, an infinitely dense point where the laws of physics break down. This bizarre and extreme geometry makes black holes some of the most fascinating objects in the universe. If black holes are truly black, how can they be associated with some of the brightest objects we see in the universe? The answer lies not within the black hole itself, but in the material swirling around it. This material forms what is called an accretion disk. Imagine for a moment a cosmic whirlpool. As gas, dust, and even stars from a nearby companion get too close to a black hole, they don't just fall straight in. Instead, they're pulled into orbit, spiraling around the black hole like water going down a drain. This collection of orbiting matter forms a flat spinning disk. This accretion disk is anything but calm and quiet. The material within it is moving at incredible speeds, close to the speed of light. As the gas and dust particles rub against each other, the friction generates an immense amount of heat. This heat causes the accretion disk to glow with incredible intensity. It can become so hot, millions of degrees, that it shines brighter than 1 billion suns combined. The disk radiates energy across the entire electromagnetic spectrum, from radio waves to visible light to powerful X-rays and gamma rays. And you know, this is the light we can actually see and detect with our telescopes. So, ironically, the darkest objects in the universe are responsible for creating some of the most luminous phenomena. When we see a quasar, a super bright object at the center of a distant galaxy, we are actually looking at the light from a supermassive black hole's accretion disk. The black hole itself remains hidden behind its event horizon, but its powerful gravity acts as the engine, powering this brilliant cosmic light show. It's like, well, a cosmic phantom that you can only see by the glowing footprints it leaves behind in the material it's about to consume. The accretion disk is also a place of extreme physics. The intense gravity and magnetic fields can create powerful jets of particles that are shot out from the poles of the black hole at nearly the speed of light. These jets can travel for thousands or even millions of light years, plowing through intergalactic space. So, while a black hole is famous for pulling things in, it's also responsible for shooting matter and energy out across the cosmos. The accretion disk is the chaotic, brilliant, and violent halo that betrays the presence of the invisible monster lurking at its center. Not all black holes are created equal. Astronomers classify them into 3 main types based on their mass. Stellar mass black holes are the most common, formed from massive stars that end their lives in supernova explosions. At the other extreme are supermassive black holes, millions to billions of times the mass of our Sun, anchoring the centers of galaxies like our Milky Way. Between them lie the elusive intermediate mass black holes, possibly hiding in star clusters or dwarf galaxies. From stellar to supermassive, these cosmic objects shape the universe on every scale. Black holes are not just passive objects sitting in space, they are active and influential cosmic architects. Their immense gravity makes them the unseen puppeteers of their galactic neighborhoods, shaping the motion of stars, gas, and even light itself. At the center of our Milky Way, for example, the supermassive black hole Sagittarius A** acts as a gravitational anchor. Stars in the galactic center can be seen whipping around it at incredible speeds, their orbits providing the most direct evidence we have for the black hole's existence and mass. Without this central anchor, the structure of our galaxy's core would be very different. The influence of a black hole extends beyond just its gravitational pull on nearby stars. As we've seen, the energy pouring out from an active black hole's accretion disk and jets can have a profound impact on its host galaxy. This powerful outflow of energy can heat up or even blow away the gas in the galaxy. This is important because gas is the raw material needed to form new stars. So a supermassive black hole can act like a cosmic thermostat, regulating the rate of star formation in its galaxy. It can effectively shut down starbirth by clearing out the necessary fuel, a process known as feedback. One of the most mind-bending effects of a black hole's gravity is its ability to warp spacetime, as predicted by Einstein. This warping can bend the path of light that passes nearby, an effect called gravitational lensing. Imagine a heavy bowling ball placed on a trampoline. It creates a dip that a marble rolling by would curve around. A black hole does the same thing to light. This can create strange visual effects like making a distant star or galaxy appear distorted, magnified, or even multiplied into several images. Gravitational lensing allows us to see the presence of a black hole by observing its effect on the light from objects behind it. This ability to shape their surroundings makes black holes essential players in the grand story of cosmic evolution. They are not just cosmic vacuum cleaners, mindlessly sucking up everything around them. They are dynamic engines that influence the birth of stars, the structure of galaxies, and the very fabric of space-time. They are part of a complex cosmic ecosystem where matter and energy are constantly being recycled and redistributed. Studying how black holes interact with their environment helps us understand not just the black holes themselves, but the life cycle of the entire universe. Black holes are invisible, so how do we find them? We can't just take a picture, but we can spot their effects. Astronomers look for stars and gas swirling around an invisible center. By tracking these orbits and applying Kepler's laws, we find massive dark objects, supermassive black holes. Sagittarius A** in our galaxy was confirmed this way, earning a Nobel Prize. We also detect intense X-rays from matter spiraling into black holes. And now, we listen for gravitational waves, ripples in spacetime when black holes merge. These clues let us uncover the universe's invisible giants. Black holes represent more than just a fascinating cosmic oddity. They are a frontier of human knowledge. They are the place where our two most successful theories of the universe, general relativity, which describes gravity, and the very large, and quantum mechanics, which describes the world of the very small, collide. The singularity at the heart of a black hole is a point where both theories must be true, yet they give us conflicting answers. Solving this puzzle, perhaps by developing a new theory of quantum gravity, is one of the ultimate goals of modern physics. Black holes are the natural laboratories where we can test the limits of our understanding. The study of black holes continues to yield incredible discoveries that reshape our view of the cosmos. The first ever image of a black hole's shadow, captured by the Event Horizon Telescope in 2019, transformed an abstract concept into a tangible reality. The ongoing detections of gravitational waves from merging black holes are providing us with a census of the black hole population across the universe. Each new observation and each new discovery brings us closer to answering fundamental questions about how galaxies form, how stars die, and what the ultimate fate of matter in the universe might be. But beyond the grand scientific implications, the quest to understand black holes speaks to something deep within us. It speaks to our innate curiosity, our desire to explore the unknown, and our drive to make sense of the vast and beautiful universe we inhabit. Black holes are a reminder that there are still profound mysteries out there, puzzles that challenge our intellect and inspire our imagination. They encourage us to keep asking questions, to keep looking up, and to never lose our sense of wonder. They are a symbol of the endless frontier of discovery that awaits us. So, the next time you think about the cosmos, remember the black hole. It's not just an object of immense gravity, but also an object of immense pull on our curiosity. It's a dark and silent mystery that pushes us to be smarter, more creative, and more daring in our scientific explorations. The journey to unveil the secrets of black holes is far from over. In fact, it has just begun. And as we continue to peer into the darkness, we can be sure that the universe will continue to surprise and delight us with the wonders it has yet to reveal. The cosmos is calling, and we are listening.